like the concept of the mole, balancing equations is one of those ideas that you learn in first year chemistry class that tends to give a lot of students a hard time, even though it is a fairly straightforward concept. I think what makes it difficult is that there's a bit of an art to it. So before we talk about balancing chemical equations, what is a chemical equation? Well, here's some examples right here, and I have some more in the rest of this video. But it essentially just describes a chemical reaction. You got some aluminum, you have some oxygen gas, or the diatomic oxygen molecule, and then you end up with aluminum oxide. And you would say, okay, fine, that's an equation. It looks nice. I have my reactants, or the things that react. These are the reactants. And then I have the products of this reaction. What's left there to do? Well, you have a problem here. The way I've written it right now, I have one atom of aluminum plus two atoms of oxygen, right? They're bonded to each other, but there's two atoms of oxygen here. One molecule of diatomic oxygen, or one molecule of oxygen, but they have two oxygen atoms here. And when you add them together, what am I? I have two atoms of aluminum and three atoms of oxygen. So I have a different number of aluminums on both sides of this equation. On this side I have one aluminum. On this side I have two aluminums. And then I have a different number of oxygens. On this side I have two oxygens. And on that side I have three oxygens. So balancing equations is all about fixing that problem. So I have the same number of aluminum on both sides of the equation and the same number of oxygens on both sides. So let's try to do that. I'll do it in orange. So I said, just what I said, I have one aluminum here and I have two aluminums there. So maybe a simple thing is just to put a 2 out here. So now I have two aluminums on this side and I have two aluminums on this side. The aluminums look happy. Now let's look at the oxygen. Here I have two oxygens on the left-hand side of the equation. And on the right-hand side of the equation, I have three oxygens. What can I do here? Well, if I could kind of have half atoms, I could just multiply this by 1.5. 1.5. 1.5 times 2 is 3. So now I have three oxygens on both sides of this equation, and I have two aluminums on both sides of the equation. Am I done? Well, no, you can't have half an atom or 1.5 of an atom. That's not cool. So what you do is you just multiply this so that you end up with whole numbers. So let's just multiply both sides of this whole equation by 2. And we have four aluminums plus three oxygens yields, we multiplied everything by 2. 2 molecules of aluminum oxide. Now, you might have been tempted at some point in this exercise to say, oh, well, why don't I just tweak part of the aluminum oxide? Why don't I put a 2/3 in front of this oxygen? You cannot do that. The equation is as it is. The molecule aluminum oxide is aluminum oxide. You can't change the relative ratios of the aluminum and the oxygen within the aluminum oxide molecule. You can just change the number of aluminum oxide molecules as a whole that you have, in this case 2. So what did we do? We looked at the aluminum. We said, okay, we need two aluminums to have both sides of that be 2. And then when we looked at oxygen, we said, oh, if I multiply this by 1.5, then that becomes 3 oxygens here, because 1.5 times 2 oxygens, and 3 oxygens there. And then all we said is, oh, well, I can't have a 1.5 there, so let me multiply both sides by 2. And I ended up with 4 aluminums plus 3 oxygen molecules, or 6 oxygen atoms, yields 2 molecules of aluminum oxide. Let's see if we can do some more of these.
So we're going to take a cue from the Khan Academy and concentrate on the first equation that Mr. Khan expanded on. So we're taking aluminum plus oxygen will yield aluminum oxide. And you want to try and balance it out. He's shown how to balance it using numbers. I'm going to show you how to do it using a visual style. So we're going to concentrate on representing these molecules via dots. So what I have here is a representation of aluminum being a blue dot and oxygen being a red dot. So on the left side of the arrow are the reactants, and each reactant is represented by visual imagery. Aluminum is a blue dot, one blue dot. O2, oxygen, is 2 molecules of oxygen, represented by 2 dots. And that whole aluminum oxide is just one big molecule of 2 aluminums and 3 oxygen. Now the purpose of this is to have what's on the left side of the arrow equal to the right side of the arrow. Alright, I'm representing each molecule with a circle. So each molecule in the equation here is represented by one circle. It's just the stuff inside of it is different for each case. So aluminum has one blue dot in it inside that circle, whereas aluminum oxide has 2 blue dots for Al2 and 3 red dots for O3. And oxygen O2 has 2 red dots in it. So each one is a separate molecule that you can't really break apart when you're balancing. So you're just going to have to multiply it to make it all the same. Looking at the left side and the right side, I'm going to work on aluminum first. Aluminum has 1 blue dot on the left side and 2 blue dots on the right side. So I'm going to have to multiply it by 2. In this case, I'm going to put a 2 on the aluminum here, 2Al, and that is represented by adding another illustration there to make it all equal. So there's 2 aluminums on the left now, 2 aluminums on the right. Whereas there's 2 separate molecules of aluminum on the left. Aluminum on the right has 2 blue dots in it, but it's still part of aluminum oxide. So now that aluminum's balanced, I'm going to look at oxygen. This is a little tougher, but we'll work around it. The way I do it is I look at O2 and I look at O3, and I'm looking at the lowest common denominator out of the 2. And I realize that it's 6. So what do I have to do in order to make both sides equal to 6? In the case of O2 on the left side, I had to multiply it by 3. So I had to multiply the O2 on the left side by 3. So let's just put a 3 right there. And that is represented by adding 2 more of those molecules, so 2 molecules. And on the right side, I had to multiply it by 2. Now, when we multiply it, it's for the whole darn thing, so it's just like adding a parenthesis to this thing and putting a 2 right here. 2 times 3 is 6, but I just got to add another illustration there. So now the reds are balanced. So now that we have oxygen balanced, there's 6 on the left and 6 on the right. We now had to revisit the aluminum portion because upon balancing the oxygen, it changed the whole situation with aluminum. Since we doubled the amount of aluminum oxide, it doubled the aluminum. It's attached to the molecule itself. So on the right side, there's 4. On the left side, there are only 2. So we're going to have to revisit it by crossing out that 2 and multiplying the aluminum by a certain number to make sure that it is even with the right side. So I look at, there's 2 here with 2 and there's 4 here with 2. So I'm going to have to take this and multiply with 4. And when you do that, you add 4 in there. And if you look at the big picture, all the blue dots are even on the left side, all the aluminums, and all the red dots, all the oxygens, are even on the left and right side as well. So the final equation is 4 molecules of aluminum plus 3 molecules of oxygen will give you 2 molecules of aluminum oxide. And now the equation is balanced.